Hello everyone, I hope you all are doing well. This is Lesson 9, Searching and Sorting. In this lesson, we will be going over various searching algorithms, including sequential or linear search and binary search. We will be revisiting the Compareto method, and then we will also talk about selection sort and insertion sort. Alright, to start off this lesson, you're going to want to go up to this folder where you have currently saved everything, and then you're going to want to launch the package. When you launch the package, you're going to want to create a new class called Lesson 9. The reason why I have already created it is because there are several methods in here that we are going to utilize. And I just want you to create the class, and then I'm going to briefly hover over each of the methods, and I want you guys to pause the video and copy each of the methods. So I'm going to spend the 2 seconds over here at the main method. Again, pause the video and take the time to copy down the code. Then play the video and you can copy down the next set of code. So here's the main method. Sequential search. Binary search. Selection sort. Insertion sort. And there you go. Alright, to start off this lesson, you're going to want to go over here, and this is where we're going to be testing out the sequential search. So I have already put down the array down here with each of the indexes clearly identified. Again, we start off at 0, and the last index is always the length minus 1. So 5 minus 1, 4. Alright, so this is the sequential search method. It is going to be pretty similar everywhere you see it, and this is like the foundation for how you're going to create it. Again, the variables could be named differently, the parameters could be named differently, could have a different structure, but the overall foundation and base for sequential search is the same. Essentially, in sequential or linear search, it typically starts at the first element in an array or array list and looks through all the items one by one until it either finds the desired value and then it returns the index it found the value at, or if it searches the entire array or list without finding the value, it returns -1. So basically, you're going to go through this entire array. One by one, you're going to check each element and see if it matches the target value. If it does, great, and you're going to return the index. If it goes through the entire array and does not find the target value, then it's going to return -1. Pretty simple. Let's walk through it. So say we set the target value at 9. Let's give it a try. Alright. We have element and target. Alright. Target is now set at 9. Target equals 9. I'm going to be keeping track of all the variables down here, and you should do the same. Alright, and then we start off our for loop with j starting at 0. Alright. Let's put j at 0. Alright, it's going to go through the entire thing until j is greater than or equal to elements.length, which in this case is 5, because the element array that we have currently passed down as a parameter has a length of 5. And then j is going to be incremented by 1 through each iteration of the loop. Alright, so we're first going to start at elements at index j. Alright, element at index j is 3. Alright, and we're using arrays right now. Whenever you want to use array list, you'd have to change it accordingly. For example, you make this elements.getJ. So just a couple differences, but overall, again, the foundation and base is the same. So we have 3. Then we see, is that value equal to the target? So is 3 equal to 9? False. Alright, because it's false, there's no other code, and we're going to increment j by 1 because we're on our second iteration of the loop. So now 0 plus 1 is 1. 1 is still less than 5. Alright, then we check elements at 1. So elements at 1 is -2. Alright, is -2 equal to 9? Nope. So we're going to increment j by 1, and now we're at j equals 2. So then we're going to check, is j at 2 9 equal to 9? Yes. All right. Then we're going to return j. All right, then we're going to return the value of 2, and then this entire method is done, and we're all good. We don't have to focus about any of this other parts. So let's give it a try. So we figured that the output should be 2, so we should get a value of 2. Let's try it out. 2, right over here. All right, now let's try another value. Let's say we try the value 50. All right, and target is going to be set at 50, and J is going to be set at 0. All right, then we go elements at 0. All right, we check if 3 equals 50. False, J gets incremented by 1, and we check. All right, elements at J, which is 1, so that's -2. -2 equals 50. False. Increment J by 1, 2 is still less than 5. Then we check 9 equals 50. False. J becomes 3. All right, 38 not equal to 50. Increment J to 4. -23 equals 50. False. J is now 5. 5 is not less than elements.length, which is 5. So this entire loop is done, and we're going to return the value of -1. All right. The reason why we're returning -1 again is because we searched through the entire array and we did not find the element that we were looking for. So let's give it a try. It should now print out -1. Here we go, -1. Sequential sort is pretty straightforward. Again, we just go through each element until we find it. If it doesn't find it, we just print out -1. All right, pretty simple. Now let's move on to binary search. So we're going to want to comment all of this out because we are done testing sequential sort, and we're moving on to the next part of this lesson, binary search. So you're going to want to uncomment the second set of code in the main method, and here's the binary search method. Take a little time to look over it as I describe. So binary search can only be used on data that has been sorted or stored in order. In other words, the array has to be in a specific order, so it can either be least to greatest, greatest to least. For example, the array has to be 0, 1, 2, 3, or it can be 0, 5, 10, or it can go least to greatest, 10, 3, 1, etc. All right? And then it checks the middle of the data to see if that middle value is less than, equal, or greater than the desired value, and then based on the result of that, it narrows the search. It cuts the search space in half each time. So essentially what's going to happen is you're going to go through this array, and it's going to determine, all right, is the value greater than whatever's on this half of the array, or is the element located on this half of the array? And it keeps doing that. So it keeps cutting the search by half. So for example, on the first one, the midpoints here, it's going to search if the element is either on this side or on this side, and then say if it decides it's over here, then it's going to decide, all right, is it on this side of the left side, or is it on the right side of the left side? And it just keeps narrowing it down. This is very good in large sets of data, because in sequential search, it is very inefficient to go and check every single element of the array to find the value in a large array. But in a large array, you can use the binary search, and it doesn't have to check every element because it cuts it in half, cuts it in half, cuts it in half. So whenever the data is short, you're going to want to use sequential search, but whenever it's long, binary search is the most efficient. All right, let's walk through it. So say we have the target now set at 15. All right, again, we have two parameters, the array we're searching for and our target value. So let's keep track of it all down here. So I'm first going to just write out the array and put out the indexes. So may want to do this as well. 1, 4, 32. All right, I think I got all of them, and then I'm going to put indexes. So we have 0, 1, 2, 3, 4. All right, here are all the indexes of this array. Again, we start at 0, and the last index is the array length minus 1. All right, then we're going to want to keep track of our target value. So target is currently set at 15. And the reason why is because we passed in the parameter 15 into the target. Oops, target. And then we have two variables over here. Left is set at 0. All right, pretty straightforward. Left set at 0, and then we have one more right, which is set at elements.length minus 1. All right, elements.length, which is 5. 5 minus 1, 4. So right now the search space is from beginning to end because we haven't narrowed down the search, so we're searching the entire array right now. The leftmost index is 0, rightmost index is 4. That's essentially what that means. All right, and then we're going to have one more middle. I'm not going to initialize it yet until we get through the first iteration of the while loop. All right, so let's do it. So left is less than or equal to right. All right, we got to check that. So is 0 less than or equal to 4? Yes. All right, we can start going through this loop. So middle, left plus right divided by 2. All right, 0 plus 4 is 4. 4 divided by 2 is 2. All right, middle is set at 2. And then we check, is target less than elements at middle? So first let's check what elements at middle is. That's 15. All right, is target equal less than 15? No. All right, then we check, is 15 greater than 15? Nope. All right, else, that's the middle. We just return the middle index, so we're going to return the value of 2, and the method is done. So we find our value at 2. It ended up actually being the first value, so it ended up working out. Here, let's give it a try. Two. Again, the index it was at was 2. Let's try a different value. Say we try the value 81. All right. I'm going to set our target at 81. Left is going to be set at 0. Right is set at 4 again, because elements.length minus 1 is 4 in this case, and middle is not initialized yet. So left less than or equal to right. So 0 less than or equal to 4. All right, we're starting. So middle is left plus right divided by 2. 0 plus 4 is 4. 4 divided by 2 is 2. All right. The element at the middle index is 15. All right, we have to check. So our target value is 81. So is 81 less than 15? No. Is 81 greater than 15? Yes. All right, we're going to run this statement right here. Left equals middle plus 1. So this left value is now going to be set to 2 plus 1, which is 3. All right, we're done with this iteration of the loop, and let's go back. Left less than or equal to right. All right, 3 is less than or equal to 4. That works out, so we're going to continue. So middle is now left plus right divided by 2. So left plus right, 7. 7 divided by 2 is 3 in this case because of integer division. Remember, in integer division, you want to chop off all of the decimals. So 7 divided by 2 would be 3.5 realistically. And then in integer division, remember in Java, we just chop off the decimals. So it'll be 3. All right, so middle is now set at 3. And that value is 81. All right, then we check. Is 81 less than 81? No. Is 81 greater than 81? No. All right, then we're just going to return the middle index, which is 3, and that was actually the index of the element that we desired. See, we only had to go through 2 iterations of the loop. This one, we would have had to go through 1, 2, 3, 4 iterations. See, it was 50% more efficient. All right, let's just see if we're right. Yep, index 3. Just like we had said. All right, let's try a value that's not present in the array. Say we try the value 100. All right, so target is now set at 100. Left is set at 0. Right is set at 4. Middle is not set yet. All right, so then we check. Is left less than or equal to right? 0 less than equal to 4. Yes. So we continue on the first iteration of the loop. Middle. Left plus right divided by 2. 0 plus 4. 4 divided by 2 is 2. Alright. Middle is now 15. Alright. And target is 100. Oops. 100. So is 100 less than 15? No. Is 100 greater than 15? Yes. So left is now equal to middle plus 1. Alright. Left is set to the value of middle plus 1, which is 2 plus 1 equals 3. Alright. Then we go back over here and see. Left less than equal to right. 3 is less than equal to 4. That ends up working out, so we're going to continue. Middle is left plus right divided by 2. 3 plus 4 is 7. 7 divided by 2 in integer division is 3. Middle is now 3. Alright. We go over here. Left less than equal to right. 3 less than equal to 4. That works. So we're going to continue. Middle is left plus right divided by 2. And we already did that. And then we check. It's 81. Target value is 100. Alright. Is 100 less than 81? No. It's 100 greater than 81. Yes. Left is now equal to middle plus 1. So left is now equal to middle plus 1, which is 4. Alright, we continue. Left less than equal to right. Yes, 4 is less than equal to 4. Alright. So then middle is 4 plus 4, 8. 8 divided by 2 is 4. Alright. Middle is also now set at 4. And we're over here at 432. Target is at 100. So is 100 less than 432? Yes. So right equals middle minus 1. Right is equal to middle minus 1, which is 3. 4 minus 1 is 3. Then we check. Is left less than equal to right? 4 less than equal to 3. That's not the case. So this loop is going to terminate, and we're going to return -1. Again, since we couldn't find the element anywhere within the array, we return -1. All right, let's give it a try and see what the computer returns. It returned -1, just like we had predicted. So again, binary search, this is how it's going to look like, and this is the format. So whenever anyone refers to binary search, this is the type of sorting method you're going to use. In sequential search, again, you go through the entire array. All right. Now, remember how I talked about you can count the amount of iterations that you do in binary search and sequential search. This is especially handy when you want to determine, all right, depending on the length of the array, what do I want to do? Which is going to be more efficient, sequential search or binary search? Well, there is a way to calculate how many iterations sequential search will take in a specific array and how many iterations the binary search will take in a specific array with a specified length. So all you need is the length of the array, which again, you can just get through r1.length or num_array.length in array list. Remember, it's .size. So in sequential search, it's pretty simple. You go through every element in the array, so all you're going to have to do is just count. That's the maximum amount of iteration that it would take, the length of the array. Because again, if it does not find it, the worst case is that you're going to have to go through and check every element in the array. Binary search, there's a specific equation to get the maximum amount of iterations that it would take, and that equation is whatever it's equal to. So you're going to have log, and we have no base, so that means that it's a base 10, and you're just going to put n, which is going to be the length of the array, plus 1. So you plug that into your calculator, and that's the maximum amount of iterations that of the while loop that binary search is going to have to run. So you can use those handy equations every time you want to figure out which loop is more efficient. All right, and then whenever you're using strings in the binary search, you're going to want to use the Compareto method. And remember how the Compareto method worked is, say you have two strings, string str1 equals hi, and string str2 equals hi. All right, and then you want to see, all right, which string comes first, right? Then you just do str1 dot compare to str2. And what this should return is this one comes first, remember, because capital letters always come before lowercase letters. And so this should return a value which is greater than greater than 0. So let's see. True. There we go. See? Again, that's how Compareto method works, and if this one comes first, then it's going to be less than 0. Pretty simple. Alright. Now that we've briefly gone over the Compareto method, let's go into the different sorting algorithms. So we're going to want to comment all of this out because we are done with binary search. Alright, and uncomment this next segment of code in the main method. Alright, so this next part of our lesson is called selection sort. So that's one of the type of sorting, and the next one is insertion sort. So let me just give you a brief overview of selection sort. So here's the method for selection sort. This is what it looks like. Selection sort starts at index 0 and looks through the entire array, keeping track of the index of the smallest value in the array, and then swaps the value at the smallest index with the value at index 0. Then it does the same thing for index 1, then 2, and so on until it reaches the length of the array minus 1. Again, because that's the last index. At this point, the array is sorted in ascending order. So essentially what sorting is, say you have the array all jumbled up and you want to sort this from least to greatest. That's essentially what this sorting algorithm does. Now let me walk through how it works. So essentially what's going to happen is you're going to search for the smallest value in this array, which is -20, and then that -20 is going to be put all the way at the first over here, and then 3 is going to be put over here. Then we're done over here, and then we go through and check the smallest value on the left, we check here, smallest value, check through this, smallest value, and then it's sorted. So let me walk through it. So let's type out the array. So we have 3, 86, -20, 14, 40. All right, and then let's put our indexes. 1, 2, 3, 4. All right? Should make sense. So let's walk through it. So here is the method again. This is the foundation for the selection sort. Anytime someone references selection sort in Java, it's going to be basically the same algorithm. Maybe it might be sorted differently, variables may be named differently, but overall it will accomplish the same thing. So we're going to loop through every element in the array except for the last one. And the reason for that is, what's the reason to sort the last one if we've sorted everything else? Again, if you go through and sort each of these elements, whatever is going to be left is this one, because you're just putting the least values, and keep swapping it. So there's no reason to check this one, because all it's going to do is just replace it with itself. So no need for that. So let's go over here, and we start with int j equals 0. All right, let's keep track of that. So j equals 0. And just the parameter is elements, and that's the array that we're sorting, and it doesn't return anything. All it will do is just sort this array. So let's go through it. So min index is set at j. All right, should be pretty simple. So min index is set at 0 as well then. Min index set at 0. Okay. Then we do k equals j plus 1. All right. K equals j plus 1, with is 0 plus 1 equals 1. All right. Over here, and this is going to continue all the way till the end. And it's going to increment by 1 every time. So Now what you want to do is check elements at k is less than elements at min index. So elements at k, 86, is less than elements at min index. So that is 3. So is this value less than this value? Nope. So what we're going to want to do is increase k by 1. Oops. K is now 2. Alright. Let's walk through it. So 2 is still less than elements.length, which is 5. Now we're going to check if k is less than min index. So k, negative 20, is less than what's at min index, which is 3. Yes. Alright. So min index is now set to k. So min index is now at 2. So essentially what we're doing is going through this entire array and finding the smallest value. So then we're going to go over and increment k by 1 again. K is now 3. And then we do elements at 3 is less than min index. So elements at 3, 14, is 14 less than negative 20? Nope. So we're going to increment k by 1 again. Now it's 4. So is 40 less than negative 20? Nope. Increment k to 5. 5 is 5 less than 5? No. Alright. So then we're done with this loop for now. And then we have temp. Alright. Temp is set to elements at j. Oops. We have temp set at elements at j, so temp is now set to 3 because that's elements at 0. J is currently 0. Then elements at j equals elements at min index. So elements at j is now going to be set to element at min index, which is negative 20. All right. And then element at min index is set to temp. So elements at 2 is set to the value of whatever's in temp, which is 3. All right, should have made sense. So essentially all we did is find the smallest value in this array and put it all the way at the 0 index, and then we just swapped it with 3, whatever was over here. Okay, now we're done with the first iteration of this loop. So now we have to increment j by 1. So j is now at 1. All right. Min index is now set to j. All right. Set j to 1. K is set to j plus 1. So k is set to 2. All right. Now all we're going to do again is find the smallest index. So it's going to go through this. So if we're going to check if elements at k is less than elements.min index. So elements at k and elements at min index, 86. So is 3 less than 86? Yes, it is. So what we are going to do is set min index to k. So min index is now set to 2. All right. Then we're going to increment k by 1 because we are done with this iteration of the loop. Then we're going to check, is elements at k less than elements.min index? Okay, we're going to check that. And then we'll see. All right. Is 14 less than 3? Answer is no. So we're going to increment k by 1 to 4 now. So then we're going to check. All right. Is elements at k 4 less than elements at min index? So 40 is less than 3. That's false. So we increment k to 5. 5 is not less than 5. So the loop terminates. All right. Then we're going to go over here. Int temp is set to elements at j. So temp is set to 86. then what we're going to want to do is elements at j equals elements at min index. So this element is set to 3, and this one becomes 86. All right, we are done with this iteration of the loop, so we're going to increment j by 1. All right, then we go over here, and this is also set to 2. All right, it's set to 2, and k is set to j plus 1, which is 3. All right, so what we're going to want to do is then check if 14 is less than 86. Yes, so min index is now set to 3, and then we're going to increment k by 1, and we check, is 40 less than 14? False. Increment k to 5. 5 is not less than 5, so we are done with this iteration of the loop. Then we check 86, then we put 86 into temp. All right, it goes back into temp. Then we set this value to whatever's at min index, which is 14, and set this value to 86. We essentially just swap those elements. So that's it. Then j is bumped up to 3, and min index is also at 3, and k is now at 4. So is 40 less than 86? Yes. So min index is now set to 4. Bump up k to 5. 5 is not less than 5, so we are done here. And then add j. We essentially are just going to swap these two elements. 6, and again temp is still 86. And then we bump up j to 4. 4 is not less than elements.length minus 1. 4 is not less than 4. So we are done with this entire thing, and we have an entirely sorted array from least to greatest. So essentially, just a brief summary, we look through for the most smallest value, and then we keep putting it to the left until we get to the end of the array. Pretty simple. So now let's move on to the next sorting method, and that is called insertion sort. So we're going to want to delete all of this because it's no longer necessary. And we're going to comment all of this out since we are done with selection sort and we are moving on to insertion sort. So we're going to want to uncomment this next segment of code. And here is insertion sort. So insertion sort starts at index 1. It inserts the value at index 1 into its correct place in the already sorted part, the part to the left of the current index. It moves any value larger than the value stored in temp to the right until it either finds the appropriate place to put temp or gets to the front of the array. All right, let me show you how it looks like in terms of visualization. So first, let me copy down this array. So 3, 86, negative 20, 14, 40. And we're going to want to put our indexes as well. So 0, 1, 2, 3, 4. All right. So, oops, I put that there on accident. This is R3. All right. So essentially what we're going to do is just go through each of these. So we're going to start here and see, all right, this is the smallest one, so it's going to stay like this. And then we go through these three, all right, negative 20. So it's going to put negative 23, 86. All right. Then we're going to check the next element, 14, and see where it deserves to go. So 14 is going to go in between 3 and 86. All right, we're done here. Then we're going to check 40. Where does 40 go? 40 is going to go between 14 and 40. So let's trace the code and hopefully you'll get a better understanding of how it works. So we're going to start j at 1. So again, we just have the parameter as the array that we are sorting. And this is also going to sort from least to greatest. So we have j is set at 1. All right. and then elements.length, which is 5, and it's going to go through everything except for the 0th index. So temp is now set at elements.j. So temp is set to 86 because that's at index 1, which is 86. And then possible index is set to j. All right. Possible index is set to 1. All right. Then we have our while loop. So while possible index is greater than 0, all right, possible index 1 is greater than 0, that works. Temp less than elements dot possible index minus 1. So possible index minus 1, that's a 0, all right. We need to check if temp is less than 0. Temp is less than whatever's at index 0. So temp 3. Oh wait, 3 is a value. So is 86 less than 3? No. So this while loop doesn't work, and element at possible index is now set to temp. So element at possible index is now set to temp. All right. The reason why we are putting the same value back that was already there is because these two values were already sorted, so all we did was just replace this value with itself. Now, when we add -20 to the equation, see what happens. So now j is incremented by 1 because we're going down onto the second iteration. And we say temp is equal to elements at j. All right. Temp is set to elements at index 2, -20. All right. Check -20. And possible index is set at j, so which is 2. All right. 2 is greater than 0, and temp is less than elements at possible index minus 1. So possible index minus 1, that's 86, is -20 less than 86. Yes. All right. So this loop is going to start. So elements at possible index is set to elements at possible index minus 1. So elements at possible index is 2. All right, this value is going to be set to this value, possible index minus 1. So now that's 86. All right. Then what we're going to do is decrease possible index by 1. All right, we decrease possible index by 1. 1. All right, then we check. Is 1 greater than 0? Yes. And is temp less than elements at possible index minus 1? So that's 3. -20 is less than 3. Yes. All right. We're going to continue on. So elements at possible index is set to elements at possible index minus 1. So elements at possible index, that's 86, and it's set to 3 now. 3, all right. And then we are going to decrease possible index to 0. All right. Then we check, is 0 greater than 0? Nope, we're done with this loop. And then we're over here. Elements at possible index equals temp. So elements at possible index, which is 0, is set to -20. Pretty simple. So let me just readjust the array since we messed quite a bit with it. All right, and see, these first 3 are already sorted. Now we're going to add 14 to the equation. So again, this is a more efficient process because all you're doing is just looking for it and then putting it in the proper place. So we increment j to 3 now. Temp is set to elements at j and possible index is set to j. So temp is now set to 14. Possible index is at 3. All right. Then we go through this while loop. 3 is greater than 0, yes, and is temp less than elements at possible index minus 1. So is 14 less than this value? Possible index minus 1, which is 2, and that's 86. So 14 is less than 2. All right, yes it is. So what we are going to do is elements at possible index equals elements at possible index minus 1. So so this value is now going to be set to 86. So all we are doing is just shifting these values to the right. All right. Then we're going to decrease possible index. And then we are going to check again. Is 14 less than possible index minus 1, 3? Is 14 less than 3? No. So what we are going to do now is this loop is now done. So then we're going to do elements at possible index equals temp. So now it's at 2. So we're going to set that value to 14. See, everything has been sorted up till this point, and now we just got one more value left. So we're going to increment j to 4. Temp is set to whatever's at index 4, which is 40. Set that to 40, and possible index is set to j, which is 4. All right. Go through this while loop. 4 greater than 0, yes it is, and is temp less than element at possible index minus 1. So 3, 86, is 40 less than 86. Yes it is, so we're going to set this value to 86 because we're doing elements at possible index is set to the value at whatever's at possible index minus 1. All right, and then we're going to decrease possible index. Then we go back to the loop, so we check, all right, 3 is still greater than 0, and then we're going to check the second statement, which is temp is less than elements at possible index minus 1. So is 40 less than 86? 40 is less than 86. So what we are going to do now is 40 is less than, hold on, give me a second. So we're checking if temp is less than whatever was at possible index. So it was. So what we are going to do now is set this value to 40 because now we do element at possible index equals temp. So element at possible index is now 40. Because it was not less than this value, we forgot to decrease possible index to 3, and then we have to check if it's less than possible index minus 1. 40 was not less than 14, so that's why we just ended that loop and put it here. Then we increment j to 5, and 5 is not less than 5, so this entire loop terminates and this method is done, and in the end we get an array that is completely sorted from least to greatest. So I hope you all enjoyed this lesson and learned something new. Again, if you did not understand any of the concepts within this lesson or have any questions about computer science in general, please scroll down to the bottom of this page and you will find information regarding how to schedule a tutoring appointment. Well, I hope you all have a great rest of your day.